we're going to take a quick look at one answer to a very common question, which is, why does 0 factorial equal 1? So let's recall that n factorial is n times n minus 1 times n minus 2, and so on to 3 times 2 times 1. If I take a numerical example, let's say 5 factorial, we know that that is 5 times 4 times 3 times 2 times 1. We also know that 4 times 3 times 2 times 1 is 4 factorial. So we could say that 5 factorial is equal to 5 times 4 factorial. Using that same idea with our variables, we would have n factorial equals n times n minus 1 factorial. And we're going to use this to look at 0 factorial. So n factorial is equal to n times n minus 1 factorial, and we're going to let n equal 1. Substitute in 1, I will get 1 factorial equals 1 times 1 minus 1 factorial. 1 factorial we know is 1. We know that 1 times anything is itself, so I don't need this coefficient. I will just have 1 minus 1, which is 0 factorial. So then we know that 0 factorial equals 1. So that is one explanation. It's not technically a mathematical proof. However, if you're going to use factorials, 0 factorial equals 1. Like a lot of things in math, things can be debated and trying to be proved wrong. I mean, after all, that's what math is all about. So there are people out there trying to prove that 0 factorial does not equal 1. But again, when it comes down to it and you're using factorials, it totally equals 1. Another explanation of this is from a combinatorial perspective, meaning looking at combinations. So when you did combinations and permutations in geometry, and you wanted to look at how you could order things, if I had, let's say, 3 people, how many different ways could I line them up on the wall, and how many different orders? So let's look at that. Let's say we have 3 letters, A, B, and C. How many different ways can I arrange the letters A, B, and C? So I could have A, B, C. I could have a CB, I could have BAC, or BCA, or CAB, or CBA. So those are the different ways that I could arrange those 3 letters. So when you looked at this mathematically, when you were doing, again, permutations and combinations, what this is, if you have 3 things, people, items, whatever they are, and you want to know how many different ways you can arrange them, that is 3 factorial. That is 3 times 2 times 1, which is 6. And that's what I came up with. 1, 2, 3, 4, 5, 6 different arrangements. So let's say that I had only 2 letters. Oops. I can do AB, or I can do BA. That's 2. So that's 2 factorial because I had 2 letters, and that's 2 times 1, which is 2. There's 2 different ways to arrange them. What if I just had 1 letter? What if I just had A? Well, there's only one way to arrange that, and it's just like that. So 1 factorial is equal to 1. But what if I have nothing? Here's my empty set full of nothing. How many different ways can I arrange my set of nothing? There's exactly one way, and it's the empty set, so 0 factorial equals 1. How many ways can I arrange one thing? There's one way. How many ways can I arrange nothing? There's one way. It's the empty set. That's why these 2 have the same value. So there's another explanation. When I started this, I said we'd look at one answer. We actually ended up looking at 2, so there's a little bonus for you. There are more explanations out there, so I encourage you to keep looking if you are interested in this. Thank you very much.